Jan Höller is a principal researcher, and well, he's got lots of exciting things to talk about. So please.
Okay, thank you. Thank you very much. Let's hope so. Good morning, everyone. Yes, Jan Höller is my name, principal researcher. I've been doing Internet of Things stuff at Ericsson since around 2005, actually. I've been engaged in a lot of external collaborations and so on. And as you can see, the title of my presentation has changed. If you expected to hear me to talk about from machine to the Internet of Things, you will be slightly disappointed, I guess, but hopefully not, because I have one slide on it. So what I will try to cover in my presentation is first to give, my personal take on what the Internet of Things is, because there are very many different opinions on what it is. And then I will actually focus on some of the key technology developments that we see need to happen to actually move towards something that is horizontalized, that Johan talked about. And then give some examples that actually goes in the direction of smart cities, and or what I call here urban needs. And it's interesting to be squeezed between two Intel speakers here, actually, because I guess Intel represents the embedded technology, and we can represent the software and the services, and Intel can represent some of the data center technologies as well on top of it that powers things. So I think that's a good match. So, but what's the interest from an Ericsson perspective here, really? And I guess many of you've heard the Ericsson vision of 50 billion devices. We talk very much around the networked society at Ericsson. How can we, through the networks and through the devices, actually empower any business or society in whole? And we have seen really a shift moving away from, I mean, we have today over 5 billion users using mobile phones, and that is the connected devices that we have today. But looking forward, we see that anything will be connected in the future, because, as we say, anything that benefits from being connected will actually be connected. And there will be embedded technology in everything. And that's where we talk about the network society. And one can speculate around the figure, 50 billion. Is it going to be 50 billion? Some people talk about trillion. An IDC report talks about 212 billion connected devices to the internet in 2020. So there's a big span, but for sure we believe that in the coming, let's say 10 years or so, there will be a tremendous impact and uptake of actually embedding technology in the environment to collect data and information. But what is really Internet of Things about? And this is, my own definition. It's really to create a digital representation of the real world, so that anything that we have in the real world, we would like to have represented in the digital realm and available through the internet. If it's buildings, what's the condition of buildings? What's the air quality and the water flowing in the pipes, so that you ensure that it's hot all the time you turn on the tap? And the energy consumption, the occupancy level of people in different rooms. That's one example. So we need to model the building as an entity and such, and in real time get the feel for how is it actually working. Or if we talk about infrastructures, we can talk about roads. How are the roads actually feeling? What's the road condition like? Is it ice on the roads? What are vibrations in structural elements like bridges, so that we can ensure that they are falling apart, and that we can plan for maintenance and these kind of things. So there are an enormous amount of different applications that you can actually envisage here. What has happened in the last year, I would say, is the phenomenon around health and fitness and these kind of things with wearables that is coming really big scale. But I would say also that not only are the tangible objects in the physical worlds like buildings and cars, etc., of interest, but also the things that generally I'm interested in, like my route to work. How can I get that as an entity of interest that I can observe? And that's not, it's like it's made up of pieces of the real world that I have an interest in. I would like to have that information in real time represented and delivered to me as a user. So this is really what the Internet of Things is for me, to create this digital representation of the real world. And what does it take? Well, you have the real world, and of course you need to instrument the real world with devices. So we have sensors that collect information, we have actuators to be able, so that we can control. It's not only about observing, but that we can control the real world. So actuators are equally key here. There's a lot of focus on getting massive amounts of data from infrastructures just to study and understand and think about the information that we have. But actuation is equally important here because we would like to be able to control things. How can we better act in the real world? How can we remotely operate in the real world through heavy machinery, for instance? And so the instrumentation here, sensors, actuators, and of course different types of tags to provide identification, like RFID, for instance, or you have even providing a QR code on something gives an identification possibility. And then you can associate a lot of information to that stupid object if it's a water bottle or whatever. And then of course you need the machinery to actually create this digital representation, data collection, modeling tools, etc. And I'll come back a little bit to that one. Now comes the machine-to-machine and Internet of Things. And this goes back a little bit to what Johan talked about. I mean, if we look at machine-to-machine, that is something that has been around for decades. And what are the main characteristics here of machine-to-machine? Well, if you look at it, it's very point problem driven. You have a single problem and you devise a solution for it. You build the verticals type of solution that Johan talked about. You deploy your device, you collect the data, and that's it. And it's very focused on your internal. If it's a smart metering, you want to collect it to be able to send out bills. So it's very focused on your internal operations of your company. It's if you look at the business models and so on, it's very much around consultancy and it's systems integration type of activities that you do. And you deploy things in-house. You put a server farm or a computer in your basement, and that runs everything. So vertical solutions. The devices are used for one single purpose only. And if you look at it from an industrial perspective, it's extremely fragmented. Each industry sector has its own practices, or I was about to say standards, but they don't even have standards because it's very much proprietary. And even if you go to one specific segment, if you talk about buildings and building automation, you have a plethora of different standards, de facto standard proprietary solutions, KNX, BACnet, LawnWorks, Zigbee, Z-Wave. There's a lot of stuff available, or people are trying to capture market there using proprietary stuff. So what differs now if we move to Internet of Things? Well, I think first of all we're going to look at a different scale of complexity in trying to solve problems. It's not like we have this single problem, but complexity. And this complexity means that we will gather many different types of data from sensors. So it's not only about, I'm going to collect electricity consumption, but you need to collect different types of data. And if you look at it from a business perspective, I think that we're going to see a lot of change in terms of we're going to evolve to something that we can talk about digital marketplaces. It's going to be part of the digital economy, how you can actually trade this kind of information, how you can buy information, and how you can actually interact across the value chain that you're in or between value networks. And how is this going to be deployed? I think very much it's going to be open web. It's going to be based very much around innovation. Cloud and as a service are going to be the some of the key elements here. And horizontal is going to be absolute key. We're going to see that devices will be commoditized. They will be generic. You can use a deployed device shall be able to be used for any kind of application. Standards, of course, are important, but equally in this space, I think standards and open source, we should not only talk about standardization in terms of specifying protocols and these kind of things. Open APIs. So that is, some of the differences between machine-to-machine and the Internet of Things as we see it. But now going over to technology, what does this mean from technology? Because I think that many claim that the technology is already here today. To some extent there is, but we need to push technology a bit further still. And I would say that they are in these 4 areas. We need to continue to work on technologies for devices. We need to continue to push for new capabilities in the networks. We need to work on providing intelligence and intelligent software, and we need to work a lot more on semantics. So I'll go over these 4 different ones quickly. First of all, as I said, the technology fragmentation is extremely important, and not even all of these standards that we talk about actually is based on IP. which makes integration difficult, which makes application development very difficult. So first of all, of course, we need to go IP. We should use the TCP/IP protocol suite for sure, and we should drive it down to the tiniest device, because that is possible today. People say that no, you can't put IP in a tiny device. It's not doable. It's too costly. It's the footprint is too large. But today you can put a tiny web server in a small microcontroller. So that is the first step that needs to be taken. Technology is there, but we need to get the market to understand that this is the way to go to reach economy of scale. The second one, I would say, is to go the web way, because everybody knows how the web works, web development and all of that. So use standard web technologies, because that will be very powerful if you want to ease integration into an enterprise environment that is based on a SOA type of architecture. And also that using standard web technologies, you can rely on the enormous developer community that is out there. Compared to if you have proprietary technologies, you need to go to the company that made the technology. They had 10 developers, and you will have to line up in a queue to get your application done or your additional fix done. Now you can have millions or hundreds of millions of developers to actually develop the applications. And of course, we should make the devices go simple. Make them application generic. Don't build these device-oriented silos. If you look at the devices that are available, many of the devices available today for IoT type of solution, you buy the device and then basically it's a fully blown solution all the way up to an app that you install in your phone. Is that the way to go? Then I buy my refrigerator from Miele, my stove from Siemens and so on. There's not going to be any interoperability. I cannot connect anything. I need different apps for everything. So we need to really cut the bond between the applications and the devices and make the devices extremely simple, so that we actually drive the value from the devices up to the cloud. That's where the value should be. And just an example, you once said that pre-standards, there are standards already available for this. And this is one example that we have been working on from Ericsson. It's how can I actually have this complete stack for very constrained devices? And that's available in a standard from Open Mobile Alliance. It's called lightweight M2M. The focus of that one was really to handle device management. But it provides you a lot more, because it provides you a framework of not only doing the typical device management issues like firmware upgrades and heartbeat, check that the device is alive, and configure connectivity and all of that, but gives you a platform for building applications. So it contains everything, and it handles, bootstrapping, registration, how you can actually tweak with sensors, how you can control actuators and all of that. And on top of that, and this can be built using any kind of business model, because you can have multiple separate applications that resides on the same protocol stack, so that you can have a number of different, let's say, application servers that you can have in different entities, or different actors can actually take their responsibility for. And on top of that, in this specification from OMA, they have developed, of course, an object model that contains all the resources and the objects that you can control from a device management perspective. But in IPSO Alliance, IP for Smart Objects Alliance, where we are part and where SIX is part, where Intel is not part anymore, but we are working on getting you on board again. We have also defined now what we call a Smart Object Starter Kit. So we have 18 different application level objects defined, capturing sensors and actuators in a very, very simple and very, very compact format. We can talk about TLV type of coding. We talk about JSON, so extremely compact. So covering stuff like humidity, temperature, lighting, presence in the room, luminosity. You can do dimming. You can change the color temperature of lights. All of that is defined in this object. And this specification is like 30 pages. 5 minutes to go. So that was around devices. The next one I said was the networks, and we are working also on what is called the 5G system, the 5G network. And here we are really looking at not only extending capacity, because it has always been a race for higher capacities, much more throughput. But now we are working very, very much on what's called machine type communication. How can we extend the future global communication systems downwards so that we can reach the tiny devices, so that we can embrace the kind of short-range radio technologies. We talk about capillary networks, so that we can integrate the tiny devices. We can ensure connectivity end-to-end, we can work with security end-to-end, and all of that. And we can meet requirements both for battery type of operated applications, where devices need to run on batteries for years, but also that we can look at mission-critical applications, where reliability is extremely important. If we talk about the grid, or if you talk about process industry and factory, and latency is really key here. So this is what we're working on. And just to show a few figures, we talk about 1,000-fold higher volumes of data. We talk about a 10 to 100-fold increase in the amount of devices, and we talk about much lower latency, and we talk about much denser environments like buildings and venues, for instance, as key scenarios. The third area is intelligence, and here it's really around the sensing. How can we take the sensor data, apply analytics on it to actually do some filtering and aggregation and reasoning, then adding on top of that, building knowledge on the phenomenon that we're looking at, building the model of the thing that we're interested in observing, like the building, and then reason about that and actually make decisions. We can put many of the decisions in the software, and that means ultimately that we can do automation. And automation here in IoT means that we turn things back, and then we task sensors to actually do something, so that we control reality as well. And this is not only just, people say that, yeah, we apply big data technologies and then we're done. But I would say that there are two different things in IoT compared to if you take the traditional big data approach here. The first thing is, of course, that even a single bit from a sensor can be, life or mission critical. So it's not around, sifting through vast amounts of data to figure out main trends. The second one is really around actuation, where you have this control loop. Then the fourth one I wanted to talk about is semantic interoperability, and that means, we talk about stuff that's happening within silos or within an organization, but as we look at the smart city, we need to have organizations, companies, etc., to be able to talk together. And we are solving interoperability on a protocol level and syntactical level with the standards that we have today. But semantic interoperability means that machines should be able to understand the meaning of the information, the meaning of the data. So we need to code that knowledge that we have in our brains into the machine, so that we don't need to have humans in between one company and the next company within a value chain or a value network. So it's really across, both in a value chain perspective, but also between actors in a value network. And there's a number of different technologies that is ongoing here to actually define, ontologies and linked data and these kind of things that we are working on as well. So these were the four ones, and of course the smart city environment is the ideal environment, where you need to integrate a number of different infrastructures at the bottom, where you instrument with sensors and actuators. You have a network that is available in every corner of the city, in every system of the city, to get up the knowledge, to do the reasoning and all of that, and then to be able to share that data. If it's towards an operations center in the city, if it's towards applications that anybody out there can build based on innovation, or towards enterprises that are stakeholders and operating in the city environment, or you can have crowdsourcing, getting information from people. Quickly, what we are doing, for instance, here, we are engaged in an EU project called City Pulse, where we are taking not only Internet of Things data from sensors and controlling actuators, but we're also looking at Twitter feeds and social network feeds to gather information about the reality. Oh, the water quality here is really poor. Twitter feed, we get that into our knowledge base. So we don't only use sensors. So we build this knowledge and reasoning system and expose this through APIs for applications. And here we are working with Siemens and a couple of cities and a couple of universities here. The second example is Operations Center. Ericsson is really big we are managing networks globally containing over 1 billion operators, and we have 4 large operating centers around the globe. And we have been looking here and working together with Telstra in Australia in how we can apply this in a scenario where we have an oil refinery and we have a bushfire outside Sydney. How can we make use of information sensors, etc., from the infrastructure, feed that into the network operations center so that they can orchestrate all the fire workers, the rescue workers, and all of that, and shut down pipelines from the oil refinery, etc. And graphically showing, all the information that we can display to the user in the operation center, based on maps around the different types of infrastructures that are overlaid here. And that's around some of the examples that we do. And there's, of course, if I talked about 4 technologies, I guess that there's people in the audience that expect, oh, I wanted to hear about this, my pet technology. I did not talk about privacy, which is extremely important. Security, how can we get security end-to-end and get security into the tiniest device? We need to work much more on that. Life cycle management, it should cost nothing to actually deploy these devices out there and then to operate them. How you need to look at this from a life cycle perspective. Planning, deployment, and operations. Business models, what are the incentives for actually participating in an open environment in a smart city? Why should I share data? What's in it for me? Business models we need to work on. Data reliability, how can I trust the information? Provenance is very important in understanding the origin of data so that you can actually ensure that you can rely on the data. So that ends my presentation. Thank you very much. If you want to read more, we have just published a book that contains all the technologies that you need to keep track on when it comes to machine-to-machine and Internet of Things. It contains use cases, including smart cities. And if you want to follow our work at Ericsson, you can look at our research blog. Thank you very much.
So thank you, Jan. We have time for one question. Yes, over here.
Thank you for the very interesting presentation. And I'm fancy about what you talk about. The device can understand the meaning of the data. And then you mentioned about semantics and interoperability. Can you talk a little bit more about this and like what techniques you have been investigating?
I mean, we are looking at how we can. What it has to do. I mean, if you look at how things work today, if you have, and this is happening even within organizations, that you're using paper at the end to actually shift something from one department to another department, or from one company to another company. So the importance here is that you should be able to, remove the person in between that actually does the translation, looking at the data, how this means this, but he talks about this, so I need to translate. And then we are looking at how can we apply semantic annotation, so we can annotate the data with well-known terms. People talk about, in the past, people have talked about building ontologies for the entire world. But now people talk more about, you have these fragments of information models or ontologies, but how can we link them together so that you can infer, based on that we have a few points that actually interconnect these models. How can you make inference and understand the meaning across? So this is the stuff that we're working on. And this project called City Pulse that we are engaged in, that is one example of a project that we're doing this kind of work. So you can look that up on the deliverables and publications.
So thanks again, Jan. I hope that we can take a few more questions in the break then.
Absolutely.
Okay, thanks.